Hi guys, welcome to Memo's Tutorials. Today we are looking at addition reactions. These are reactions occurring in our organic compounds. So the first one that we're going to talk about is hydrogenation, followed by halogenation, hydrohalogenation, and lastly hydration. So when we're talking of hydrogenation, we are simply adding a hydrogen molecule in the presence of a nickel or a platinum catalyst, right? So our alkene that we are going to be working with today, it's ethene. Okay, we are working with ethene. Ethene it's a 2-carbon compound and it has a double bond there. So we are reacting it with hydrogen. So what happens is that the double bond is going to break. When the double bond breaks now, our carbon-carbon bond, it's left and very unstable. Remember, for a carbon molecule has to form 4 bonds, right? So here we have 1, 2. And because we have removed or we have broken the double bond now, we are left with an unstable carbon and another unstable carbon there. But the good thing is, since we are reacting this with hydrogen, a hydrogen molecule, it's coming to, this hydrogen molecule is going to come and bond with this carbon, and the other hydrogen will also come and bond with that carbon. So at the end of the day, we are having our alkane, which is C2H6, right? 2 carbons and the 6 hydrogens. This then gives us what we call ethane. Okay, that's for hydrogenation. Using the same example, using the same molecule of ethene, now we are moving on to halogenation. The catalyst is still the same. We can use platinum or nickel as a catalyst. And now, when we're talking of halogens, we're simply talking of group 7 elements, right? Which include fluorine, chlorine, bromine, and iodine. And we are reacting, in this reaction, we are having our ethene and we are reacting it with a bromine molecule there. So what will happen is, firstly, the double bond will break. As the double bond breaks there, a bromine molecule will come to stabilize this carbon. Remember, this carbon is now bonded to 3. It's having 3 bonds instead of 4. The bromine will come and bond here, and the other bromine molecule will go and bond there. I'm sure you can see it's Br2, right? Meaning we have 2 bromine elements, 2 bromine atoms there. So now, as the final stage, we are going to have our carbon bonded to our carbon. All this carbon will be having a bromine molecule. And this whole compound, we call it a haloalkane. These are haloalkane because some of the hydrogens have been replaced by a halogen. And the name of this haloalkane is dibromoethane. Di means 2, bromo is for bromine, ethane is for our longest carbon-carbon chain, which is just 2 carbons there. Okay, so now we are moving on to what we call hydrohalogenation. So for hydrohalogenation here, we are having a hydrogen that has reacted with a hydrogen that has reacted with a halogen to give us a hydrogen halide, right? Hydrohalogenation, hydrogen plus halogen. Okay, so now when we react our hydrogen and our halogen, we get what we call a hydrogen halide. So these hydrogen halides includes hydrogen fluoride, hydrogen chloride, hydrogen bromide, and hydrogen iodide. So in this particular example, we are reacting our ethene with a hydrogen chloride. Okay, this is the hydrogen chloride. Like I said, the double bond will break and will remain with 2 unstable carbons there. And also our hydrogen chloride will break. The H will go and bond with this carbon, and the Cl will go and bond with that other carbon. So at the end of the day, we are going to have a very stable haloalkane, right? But in this case, we are only having just one chlorine there. So it's not going to be dichloro because we are having one chlorine. So this is chloroethane. Okay, hopefully you guys are following. And then lastly, we said on addition reaction, we have what we call hydration. So as for hydration, we are hydrating it using water. So we are reacting our ethene with water, but in this case, our water is in the form of steam, and the catalyst that we are using is phosphoric acid, right? So phosphoric acid is H3PO4, yes. So now we are reacting our ethene with steam, okay? Our water is in the gaseous state, right? So what happens is our water, we have a hydrogen and an OH, it's H2O. We have a hydrogen and an OH. So as we react them, our water, it breaks, and at the same time, our ethene bond there, double bond, is also going to break, leaving us with two unstable carbons there. So the hydrogen molecule, one hydrogen will go and bond with that carbon, and the OH in this case goes to bond with that carbon. So at the end of the day, now we are having our stable molecule, which is an alcohol. It's an alcohol because we are having an OH group. And what's the name of the alcohol? It's ethanol, 2 carbons,